Hello students, this is Miss Dalton. Today's topic is on what's my rule. So I want you to recall that a function can be a rule with input values that are domain and output values that we call the range. When you put an input value together with its output value, then you have an ordered pair. So we saw this with the last topic where you took some domain values and you plugged them in for x, and then you got some range values, and then we paired those up, and those were ordered pairs. So on example 1, where it says explain what the ordered pair means, the way I want you to describe that is that when you input an x value, there's my x value, so an x value of 2 into your rule or function, because when another name for rule is function, then it generates an output or y value of the y value is 7. Okay, if you have 2 or more ordered pairs that were obtained from the same rule, then you can find this rule. So in other words, if we have 2 or more ordered pairs that come from the same function, then we can figure out what that function is. So now what we're going to do is we're going to look at a table, and we're going to try and figure out what the rule is or what the function is for these ordered pairs. So the first thing that you're going to do when you have this is you need to figure out what the x values are increasing by and what the y values are increasing or decreasing as. So if you look at this table, in between the x values, they're going up by 1. Okay, in between the y values, what is the difference in those? Well, between 6 and 12, if I add 6, that gives me 12. And let's see if it keeps happening. Yep, when I add 6 again to 12, I get 18. Add 6 again, I get 24. Add 6 again, and I get 30. Okay, this is what we call the constant rate of change. We've already done this a little bit, but we were working the other way around. I was giving you the rate of change, and you were having to build a table. Well, now we're given a table, and we have to work backwards to figure out what our rate of change is. The rate of change will always be written as a ratio, and it's the change in the y values over the change in the x values. Okay, so what was happening with our y values? The change in our y values was plus 6. The change in our x values were here, and it was just over 1. Okay, so if I simplify that, that's going to be the same thing as just 6. So my rate of change, or my constant rate of change, is 6. This ratio will appear as the coefficient of x. So if you think back to how we did our tables, that rate of change was always getting multiplied by x. Well, it's the same thing here. The ratio is going to appear as the coefficient of x. So my rule, it appears to be that y is going to equal 6 times x. That's what it appears as my rule. Because again, the rate of change, the ratio, will appear as the coefficient of x. So it's going to be the number that goes in front of your x. Now let's take one of the ordered pairs and plug it into the rule to see if the equation balances. So if we take this equation, y equals 6x, and we just choose one of our variables, it does not matter which one we choose. Let's go back and look back up at the table. Let's take this 424. If I take the 424, then that means that the 4 is going to go in place of x, and my 24 is going to go in place of y. Is this a true statement? So that's what I'm asking when I'm trying to decide if this is my rule. Well, 6 times 4 does in fact equal 24. So it appears that this rule is correct. So my rule, or my function, for this table looks like it's 6x. And you can go back and you can check all of these ordered pairs. If you look at this ordered pair here, 6 times x, 6 times 5 would equal 30. This one here, 6 times 3 equals 18. 6 times 2 equals 12. 6 times 1 equals 6. So you can see that the rule does appear to fit. Okay, example 3 has this table, and I just rewrote it on this page because it was coming from the other page. Step 1, what is your constant rate of change? So again, you want to remember that you're going to do the change in y over the change in x. Okay, so if you look at how these are changing, my y values from -1 to 1, I had to add 2. From 1 to 3, I had to add 2. From 3 to 5, add 2. So on and so forth, right? Okay, the x values from 1 to 2 was adding 1. From 2 to 3, adding 1. And so on and so forth. So you can see that the change in the y is 2 and the change in x is 1. Therefore, my rate of change is 2. Step 2, how will this appear in your rule? Well, remember, the rate of change will always be the coefficient of x. So it appears that my rule might be y equals 2x. Okay, step 3, you're going to pick a random point from the relation to determine if the equation balances. So let's pick 3, 3. Again, you can pick any of these points to plug it in to see if it works. So if my 3, 3 works, then 3 would be my y value. And it would be equal to 2 times my x value, which is 3. And so I'm going to see if this works. Well, 3 does not equal 6. So no, this does not work. So what's going to happen is, now you have to decide what needs to be added or subtracted to the end of this rule in order for this to balance. Well, if we look at what we got, 3 equals 6. What could I add or subtract to this 6 to get it to balance? So what would I have to add or subtract to get that to be 3? Well, what you would need to do is you would need to subtract 3 in order for that to balance. Then you would have 3 equals 3. Okay? So what happens is, what you had to do to balance, you need to add on to this rule. So I had to subtract 3, so therefore my rule up here needs to have a -3 to it. So my rule is really going to be y equals 2x minus 3. You only have to do this step if it does not balance. Okay? So this step's only necessary when step 3 does not balance. You have to determine what needs to be added or subtracted so that it will balance. Now, just to make sure that it does actually that that rule does actually work, you want to pick another value. So let's look back at our table. Let's go ahead and pick this one here, 6, 9. So let's take the ordered pair, 6, 9, and let's check it to see if it works. Well, this is my x, this is my y. So in my equation, y equals 2x minus 3. You want to plug in those values. So y is 9. And does that equal 2 times 6 minus 3? Does that work? 9 equals 2 times 6 is 12 minus 3. Yep, in fact, that does equal 9. So it looks like my equation works. Yay! Y equals 2x minus 3. Okay, guys, that's it for this weekend. Come to class ready to work on these problems. Don't forget to submit your WISC. I don't want to have to hand out D-Halls. Oh, shout out to my first period. They are the first class ever in my past 3 years to get 100% submitting of the WISCs. Good job, first period.